Hello guys, so this is our question for section 2.2. This is question number 10, but you'll see this kind of question a lot. This one we're talking about an athlete whose event is the shot put, but this could be throwing a ball through the air or a football or shooting an arrow, anything that follows this kind of parabolic path is going to work generally the same way. So it gives us a function here to model the path where x is the horizontal distance in feet from the point of release, and f of x is the height, I believe, when the shot, his path is shown. It's height is f of x. It was right there in front of me. I missed it. So we're going to answer several questions. Part A is asking us to find the maximum height and how far that height is from the point of release. Okay, so we're trying to find the maximum height and how far is that maximum height. Not how far till it hits the ground, but how far to get to the maximum height. So we have a formula, because we could you can kind of try and look at the graph, but honestly you can't get an exact answer. We know about where it should be, but this, you cannot get an exact answer from this. So to find that, the x of the vertex of any parabola is going to be negative b over 2a. That's a formula for the x value of the vertex. The x value of the vertex. So b and a come from our equation here. B being the 0.7, a being the negative 0.01. So we have negative b over 2a. Okay, so let me see if I can do this without messing it up. Okay. Oops. Come on now. Okay, so typing this in your calculator obviously is going to be a little bit easier than my little computer calculator. But if you type that in, x is going to end up being 35. Now we have to be really careful. 35 is not the maximum height. 35 is the x value, meaning the how far away the horizontal distance is 35. This is 30, so 35, so right here, 35. The height we find by actually plugging in to the function. Okay, so you're going to plug that into your calculator. Okay, and for that one, I went ahead and got my regular calculator, and plugging it in, I got 17.85. So this is why we really can't base it off of the graph, because there was no way for us to know that this was 17.85. We had no way of knowing that. So you have to base it off of the formula. So what we have found is that the maximum height is 17.85. 17.85, and it occurs 35 feet from the point of release. Now this says type an integer or a decimal rounded to 4 decimal places as needed. So we don't need all 4. We're just going to put 17.85. But if it had more decimal places, I would have to pay attention to this needing 4. Okay, so the next question. What is the maximum horizontal distance to the nearest tenth of a foot, or the distance of the throw? Basically, how far does it reach before it hits the ground over here? So the key thing with hitting the ground is that my height is 0. That is the key thing here. If it is hitting the ground, that means my height, or f of x, is 0. And we want to know what the x value is when the y value is 0. Well, you could try factoring that if you wanted to, but it's going to be real ugly. So your better option is to use the quadratic formula. Anytime it's set equal to 0, you can use the quadratic formula. So it's negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Alright, so really important that you have that memorized. So I'm going to pause for a second, get my calculator, and work that out, and then I'll be right back. Okay, guys, so if you simplify what's under the square root, you get 0.714. Then essentially what you have are 2 different possibilities. You can work this out using addition, and you get negative 7.2. But that answer doesn't really make sense because that answer is back here, negative 7.2 on the x-axis. We don't want that answer. So if you work it out again using a minus, you get a positive 77.2. That makes more sense. That's where we want to be. So our answer for how far this goes before it hits the ground is 77.2. Making sure I round to 1 decimal place because that's what it says. And that's it. Okay, so you definitely got to be careful. You can get 2 different answers with the quadratic formula. Only one of them will make sense for what you're trying to do. All right. From part C is actually really easy. From what height was the shot released? Okay, from what height was it released? Let me erase some of this for a second. If you're thinking about from where it was released, that means from where he threw it, your horizontal distance is 0. Your horizontal distance is 0 because it hasn't gone anywhere yet. So you're plugging in 0 into your function. Whoops. Can't talk and write at the same time. And what you'll notice is everything's going to turn into 0, right? This is 0, this is 0, except for that last number. That last number is always going to be our answer for this kind of question. It is released from 5.6 feet in the air. Because you got to think about this athlete's the one throwing it, right? So he's not throwing it from the ground. It's up in the air a certain bit. So you can kind of see that here. But again, you wouldn't be able to know that that's 5.6 unless you had the function. Okay, so we base it off of the function. Okay, so that's it for this question. If you need help with any of these questions, make sure you send me an email. Thanks.